In the previous chapter, we discussed about elements of a class, and I'm sure you would have got an understanding of the core elements of a Java class. In this chapter, we will discuss about object lifecycle. What is an object, and what are the core lifecycle stages? Like, we have three stages. One is creation, manipulation, and the last one is destruction. So we will discuss about these elements in detail in this particular chapter. Let us explore object lifecycle in detail. So coming to an object, so if you look at an object in general, object is nothing but an instance of a particular class, of any class for that matter. Say for example, we have a class called a rectangle. An instance of that class is basically a rectangle instance, okay, also known as an instance, which is nothing but an object. So finally, to create that object, I need a block of memory. So Java uses the memory which is there in the operating system, and that is a memory known as heap memory, and it is always in the heap memory that the object is created in Java. And it is modeled over real world entities, as we have already discussed a couple of them. We have a rectangle class which is modeled on a geometry rectangle object, and then we have based on domains. In the previous chapter, we discussed different types of classes that are there based on the domain. For example, if you are in a banking domain, you have a class called customer, account, etc. So these are some of the things which is the beauty of object-oriented programming, where we model the entities based on what we see in our day-to-day lives, so that it's more easier and more closer to the domain where we are solving a problem. Next, an object maintains a state. For example, what is a state? A state is nothing but some variables which is basically present in a class, and whenever we talk about an object, it is basically the value of that particular variable. So we know classes contain variables, and when you create an object, some value will be there associated with that particular variable, where we would have given that information as part of the program. For example, when we created a rectangle object, probably we give a width and a height. So that is nothing but the state of a particular object. And object also implements multiple behaviors. So various functionalities that are required to be exposed by an object is implemented using the concept of a method. And what is life cycle? So we have three important elements. One is creation, where an object is created, and we have manipulation, where the object is manipulated, which means the state of the object can undergo a change, and then it gets destructed. So when you create an object, a block of memory is assigned, and when you destruct, or a destruction cycle, what happens is that particular memory is released. So that's a basic life cycle of a Java object in general. So let us look at creation cycle. It is created using the new operator. So new operator is a very important element in object-oriented programming like Java, and it allocates memory for the object and invokes the constructor to initialize the object. For example, if I create an object, I need some initialization, for example. So in this case, we have a constructor which can be used for initializing the variables, and that is another way we could say creating the initial state of the object. And not only that, the new operator also creates, for example, a reference to the new object that is basically created. For example, as you see here, we have a new object called student created as an instance of a class called student, and you initialize by passing name as a parameter. So this is where the constructor comes into picture. Similarly, a rectangle which basically takes width and height, so that data is basically being passed. So the variable student, the small s student and the small r rectangle, what you see here is nothing but a reference variable, which means it is basically a variable which is actually referring to an object and holds the reference of that particular object. This does not have literally any information as such. So only using this variable, for example, student dot some methods can be executed, rectangle dot some methods can be executed, or rectangle dot some variable could be accessed. So that is how an object is accessed via the dot operator as well. So that's about the new operator which is there. And coming to constructor, so constructor is basically any other method, like similar to an arbitrary method, which is basically used for creating objects of a class having the same name as the class. So what is the difference between other methods and the constructor? So constructor will have the same name of the class. Say for example, if you have a class called student, there will be a constructor by name student. A class can also have multiple constructors. We'll see all those details in the later courses. Next, we can initialize the attributes in the constructor. And what is an attribute? Attribute is nothing but certain fields which are basically part of a particular class. And then a class can have multiple constructors and optionally can take multiple parameters also. So this is very much important. And we do also have a default constructor in Java, which means a constructor which does not take any parameters. That is generally referred to as a default constructor. And it is not mandatory to declare any constructor or even the default constructor in Java. So by default, the constructor will be given and it will be implied. So the default constructor is implied. In case you want to create any other additional constructors which requires some parameters, etc., then you need to basically go ahead and create one. And it is mandatory if any other constructor is declared, and default access is also required, which means if I need a rectangle object to be created as is without passing any parameters, and I have already created a rectangle constructor which takes width and height, in that case default will not work by. So you have to explicitly declare one default constructor and define the logic within that particular constructor as well. So this is one thing which is important. We will see that as we go ahead with our environment and other lab exercises. Okay, so next is about manipulation. So the second step of the life cycle is manipulation, where methods are invoked to manipulate the internal state of the particular object or instance. So an object actually encapsulates its variables, and it is possible to have a private variable which we already discussed, and this private variable can basically keep that particular data well within the object scope. So what are the methods basically used for? So it is basically called on a particular object. So I cannot invoke the method of another object automatically directly by referencing that particular variable. So if we're referencing a rectangle object, for example, I can invoke the methods only of rectangle class. If I am referencing a student object, I can invoke the methods of student class only. And then we also have static methods, which are also referred to as class level methods, and they can be invoked directly by creating a prefix of the class name. So you don't need an object per se if you are just invoking a main method, or sorry, a static method. Okay, main method itself is a static method, by the way, and that's where we don't really require any object to be created. Instead, the main method will be directly invoked. And this is an example where you see an invocation of a static method where math is a class. It belongs to java.lang package, and then math.square root of some variable x or some data x is something what static method is all about, and it returns the square root of that particular number what you pass. All right, so this is about manipulation, And let us come to the last element of Java object lifecycle, which is nothing but destruction. So when you talk about destruction, so first thing we need to understand, there is no destructor in Java. Other programming languages, for example C++, also comes with another explicit destructor definition. Java does not have any such destructor. Then an object is destructed by a separate background thread called garbage collector. We have already talked about garbage collector in the previous classes, previous chapters, and this is the place where the garbage collector will remove the object from the memory when an object is dereferenced. What do we mean by dereferencing? When an object is no more required, you could basically make that object as null. For example, if you have said student S is equal to new student, and after some time when you have done with that student object, when you don't need, you could also dereference it by saying S is equal to null. This is a simple example of dereferencing an object. Or if you assign a different reference object, for example, S is equal to new student, and you are now assigning a different object and referring to a different student object, in that case the previous student object will be also dereferenced. So that is second option. Similarly, whenever you create an object well within a particular method, and once the method is executed and completed, all the objects that got created within a method will also be dereferenced by default. So these are the different behaviors that we can see in Java. And coming to the garbage collector, it's a very important element of Java technology, and it is basically nothing but a background task for deleting the object that got dereferenced. So it's more of like a cleaner. So it just cleans up all the objects which are basically no more required by the Java program. And by doing so, it will free up the memory allocated. Remember, when the object is created, a block of memory will be assigned. For example, if an object contains 10 integers, so the 10 integer values worth of data will be required to be stored in memory, and that will be released. And that is what is a free up logic which we have in the garbage collector. So the developer really worries about creating the objects and need not really worry about dereferencing or releasing the object data or memory. And this is one of the advantage in the Java programming world, where one need not really worry about releasing the memory. And whenever we want to get notified when an object is removed, so we do have a method called finalize, which we used to use. So finalize method is invoked just before an object is being deleted by the garbage collector, or before the object is released or the memory is freed up. This is invoked by garbage collector thread, which is a separate task and a separate thread which will be not under the control of the developer. So keep that in mind. And if you want, we can also override this particular thing. So let us just quickly look at an example of using the garbage collector thread and seeing that how it will basically remove this by using an implementation. So let us go and do this implementation here. So for this purpose, I have created a simple class called rectangle. So we already have seen this structure. For example, we have a class called rectangle, and now I hope you are able to understand what is this thing. This is a private integer length, which is nothing but a variable, and then we have width, and we have rectangle, which is basically having a constructor here, and then we basically initialize the length and width, and we have a method called getArea where it will return the area. And then finally, the most important thing is the finalize method. So finalize method is something which can be overridden from java.lang.object, which is a superclass for all the classes in Java. And we have system.out.println we have given just for the sake of getting you the information. So we are saying that it's inside the finalize method, and it is important to invoke this method by invoking this super dot finalize. So what is this super keyword? What is throwable? All those things we'll see in the next course when we get into more detailed programming of Java. Now, let us go ahead and write a simple program here to understand the object lifecycle. So object okay, so object lifecycle, I need a main method. Okay, all right, so a rectangle. So we could call any reference variable. Say this is the class rect. I can call it as a rect. So that is, it's not mandatory to use rectangle as a variable name, which is a best practice found in the industry. That's it. That's the reason we have been using this. So new rectangle of giving length and width, say 30, 40, for example, and then now I am referring rectangle object with rect reference variable, and that saying get area, and I can also dereference this particular thing. We'll see this particular object being dereferenced. We could say is equal to null. So the moment I do this, it is dereferenced. So if I try to again access rect.getArea, I will get an exception, null pointer exception, because it is not referencing to any specific object. Okay. So next is we could say I am now invoking GC. So the garbage collector typically will be invoked in the background, but if we want, we can also give a request for invoking the garbage collector to the JVM process. So let us go ahead and say system.gc. So this is just like a request given to the JVM to do a garbage collection cycle. Okay, and then we will basically see the output. So this is after GC call, we could say. Okay, let us run this simple program here. Okay, so as you see here, so it's inside the rectangle constructor, which means first rectangle object is created. So we could also navigate to the different classes. So all you have to do is just hover over this particular place and hit the control button in the Windows keyboard, and you could see there is an underline getting created. So if you click on this, you could also navigate to the class of your requirement. Okay, so this is also useful from a developer perspective to use the IDE more effectively. Now inside the rectangle constructor, and then it got initialized, and then we says it is initialized with length and width, so on so on. Next we are saying inside the get area method. So if you come back here, we are invoking the get area. So here also, if you want to get inside this particular method get area, so here we are saying that yes, I can go ahead and look at this, and it is returning the value. So this is where, and then we are saying invoking GC. So when GC is invoked, so we see that super.finalize is coming into picture, and here we see that inside the finalize method. So if we want to release some resources and use this particular method for clearing some memory, etc., which we can do, but it is not a very effective way. I will tell why in the next section. Okay. All right. So this is about a call for dereferencing, and even if you don't dereference here, if it is a long running process, yes, this would basically make sense. Or if I say rect is equal to another rectangle, new rectangle of say 50, 50. So this is another option where we could see that now we have created a new object where the existing object is now dereferenced automatically. So the first rectangle object with 30, 40 has been dereferenced. Let us look at this particular thing here. If I do a rect area dot get area, you could see this thing that inside the 50-50 rectangle here. So let us just go and run this program. So now you will see this inside this particular object, and whenever we say get area, it is basically getting the area of the second object. So this is very much important. And here again you could see that even though we did not really call rect.null, it got finalized. Which got finalized? It is the first object that got finalized. So this is a simple example where we see that it is inside the finalize method. And in case if I say rect dot finalize, oh sorry, not finalize, we say is equal to null. So this is another place where we could directly see the output where the finalize will happen for two objects. So here you see that inside finalize, inside finalize. So these are the two objects which are getting finalized in this particular place. So this is an example of how this works. But you would have also observed that when you did not dereference the object, I did not get two finalize method, which means this got invoked anyway. After the JVM was shut down, it was basically removed by default by the environment, but it did not invoke this particular method. So there could be a flaw that finalize method might not be invoked. So this is one of the thing, and it is not under the developer's control. So there are certain flaws with finalize method. So what are those? So it's unpredictable execution. So we saw in the demo that it might or might not be invoked, because when the JVM directly shuts down, it is possible that it will directly release the memory, but it will not invoke this particular object. So this is unpredictable execution, and developer does not have control over the invocation of finalize method. So this is very much important, and it also brings an additional overhead to the garbage collector, and that can kill the performance of a Java application. So how do you address this problem? So we have some alternatives. So since it is not a very good option in JDK 9, this was also deprecated and it is marked for removal. So it is better to avoid finalize. So here in this chapter we demonstrated so that you will be aware of this particular method, but in the later courses I will talk about other alternatives, like we have something called try with resources, and we also have a neat implementation called cleaner API. So we will talk about this in the later chapters or later courses. Okay, fine. So this is about object lifecycle, which gives you an idea about the entire lifecycle of an object and what are the three important stages in an object lifecycle. So I see you in the next chapter where we will do some hands-on. So we have learned about how the object lifecycle looks like. So let us do some hands-on in the next chapter.